This is our pleated belt filter air filtration system. As you can see, it's composed of different modules and components, including the inlet section, a rotary filter section, a pleated belt filter section, and a fine filter section or policing section on the end, plus an outlet with its fan and cooling grid. This machine right here is used primarily for testing woven and non-woven textile fibers and dust. Filtering dust by itself is relatively easy. Filtering fibers by itself is relatively easy. But when you combine the two, where you have very fine dust, I'm hoping you can see that, plus fibers, it becomes a very hard thing to do. This machine was developed with that specific purpose in mind. This is the kind of material, real light and fluffy, that this machine is set up for. Right here is a feeder. We feed or auger the dust into a vacuum pipe. It goes into a fan. The fan busts the dust and fiber into small pieces and injects it into the inlet of the inlet section. Now, we just showed you where the inlet is and the air's coming from. That air is actually coming underneath here and blowing the dust up against this here screen, plus the fiber, this material right here. The fiber will catch on the screen, but the fine dust will go through this fairly open screen here. Now, after a while, this disc will be totally covered with this kind of material. Now, this is good material. We want to save this and recycle it back into the plant. Now, what we're going to do here is turn this on and show you how this nozzle here will suck this material off this screen. Jim, if you'll turn it on for me. As you can see, the nozzle is traversing across a screen that is rotating. And that way right there, it can catch all the material across the whole screen. And it does it fairly quickly. One of the best places for this type of machine or application is in baby diaper manufacturing, feminine hygiene products, and things like wipes or cotton swabs or cotton balls, things along those lines. It is very hygienic, it doesn't trap a lot of dust, and it's able to clean very deep even in high moisture conditions, so we don't have what we have, a Legionnaire's disease problem. We are now inside the pleated belt filter section of the EverClean system, and this is what the fine dust filter media is for. This here is a pleated belt. It has a PTFE membrane on it. This particular size machine right here, and this is about a 30,000 CFM machine right here, this 4-cell wide. It has 4 cells in it and thousands of square feet of filter media. So we're allowed to run the air filter cloth rate or filter rate very low in here, ensuring we get a very fine cleaning ability through this filter. Now, the fine dust that went through the rotary screen comes this way and is deposited on the filter media. As you can see, the pleats are very close together. Now, even though it is fine dust, that fine dust would clog these pleats totally up and no air would go through it unless we cleaned it. As soon as we get a big filter cake on here, this machine senses the pressure drop and it says, I need to clean. Now, normally it would clean cell number 1 to start with and work its way across, but because of the position that we're at, we have to show you this cell right here because this is the only one you can see. So this dense filter media is actually going to rotate like a conveyor around this cell right here is what we call it. Now, the way it works is when it rotates and goes around the bottom and the top pulleys, it's going to open up, sort of like my fingers open up. That gives more space in between for a vacuum slot in the floor to suck the dirt and dust actually out from between the pleats. Now, to assist that mechanism, we also have a pulser in the pulley that actually pulses at the same time. That way, when this filter media goes around the pulley on the bottom, it almost cleans it back all the way down to brand new. That's why we like to use PTFE membrane on the filter media, because that doesn't require a dust cake for high filtration efficiency. Jim, if you would, I'd just like to see the media rotate. I'm hoping you can see that. You can see the media is actually rotating around the cell. Now, if we had the air pressure on, you would hear a pulsing going on down here in the floor. Right now, I'm in the fine filter section or policing section. That's right behind the rotary pleated belt filter section. Now, we got to remember that the rotary pleated belt filter is an extremely efficient filter device. So that means that very little or hardly any dust is actually going to get through it to get into these filters. This is really a backup type situation in this particular machine setup in case we get a hole or some mechanical damage occurs to one of the cells or the pleated belt. In that case, the dust would be caught by these final filters, which are extremely efficient, and the pressure drop would go up and signal the operator or plant maintenance team that there is a hole or something wrong in the system, probably in the pleated belt filter section. These are also the same type of static filters that go into gas turbine situations, so you can imagine the efficiency of these. These are what we call ASHRAE 95s in this filter right now. This is the back side to the policing or final filter, and roughly this little section right here allows the air to get straightened up before it enters the inlet to the fan. That's basically all we do back here. This door right here in this little room provides access to the fan and the bearings inside there. This is an ID fan. It's an induced draft. This is a negative system. It could be a positive system, but the way we have it laid out here, it's a negative system. And there's the fan discharge going out the top. This particular one here has a cooling coil section embedded in it up here that we can cool the air in case we want to loop it around and just continuously process the same air over and over again. The controls for the pleated belt filter are modern and up to date. As you can see, they're digital with an output-input screen. It is also PLC controlled. What that basically means, this machine and all its functions can talk back to the LAN unit or internet unit within the plant.